Hello everyone, and welcome to the first ever live stream by the Dutch Java User Group. My name is Bert-Jan Schrijver and I'm your host for today. We're really happy to have Sander Mak as a guest for our live stream. So Sander is Director of Technology at Picnic. He's a Java champion. He's the book author of Java 9 Modularity, and he's presented about Java at more conferences than I can count. And now he's ready to walk you through the new features in Java 14. So if you have any questions during the session, please ask them through the YouTube chat. I will gather your questions and ask them to Sander whenever it's suitable. So without further ado, it is my pleasure to hand over to Sander Mak.
Thank you, Bert-Jan, and welcome everyone. First of all, thanks to the NLJUG for organizing this. I think it's a great way to get the community going, even though we cannot physically meet. This way we can keep on sharing knowledge and keep on being a community. So thank you for joining, and I hope we have a great afternoon together. So this afternoon will be all about Java 14 and especially the language changes that are in there. And as a Java champion, I've always had a keen interest in the Java platform, the Java language, the evolution of it. And looking at what's happening in Java 14, I think there are some pretty exciting things going on. There's also a slightly different perspective which I look at this, because I'm also part of the tech leadership team at Picnic, and all our systems are Java-based as well. So we're very interested to see how Java evolves and how we can adapt. Even if we might not go to this new version right away when it's released, it is, I think, for all of us very important to see what's in the language, what's in store, and how we can move on with this. Now, obviously, it's also a very special time for Picnic, being an essential company in these times. So yes, we're very, very busy developing software, but at the same time, we also do take time to look ahead at new developments like Java 14. So what I would like to share with you today is what we learned when looking at Java 14. And before we dive into the code and into the features, let's put this release a bit more into a perspective. So when you look at Java itself, we all know that Java 9 was the last very big release with a module system. This is something that I've written a book about, so it's obviously a very big release where you can talk for hours. But then we got into a release schedule where we get a new version every 6 months. So now we're already at number 14, which means that a lot of versions have come and gone already, 9, 10, 12, 13. But 8 and 11 are quite special in the sense that Oracle and the wider community around this has designated these versions, so Java 8 and Java 11, as long-term supported ones. At Picnic, we're currently running our systems on Java 11, but that does not mean that we don't look ahead, because we do know that Java 17 is also coming up as a next long-term supported version, and everything that happens in between affects us as Java developers, especially if we want to make the move from LTS releases like this. So a common path that I see is people going from Java 8 to Java 11 and then planning to go to Java 17 when it's out as a long-term support release later. But that does not absolve us from the responsibility of learning about what's happening in the Java language. And in fact, if you follow closely and if you're agile as a team, you might very well also adopt these releases as they come in. So without further ado, I think it's good to look at what we're going to discuss in terms of Java 14. Relatively speaking, it's a bigger release than, for example, Java 12 and Java 13 in terms of the features that are in there. So we have to make some choices. And the choices that I'm going to make is that I'm going to look at language features. So things that change the Java language itself. Because I think these are most impactful, and as programmers, we're really interested in this. Of course, there are many JVM and platform changes, and we'll highlight a few of those towards the end of the stream. But the demos and everything around this will be about the language changes. The first one being the switch expressions, a new feature in Java that is actually fully baked and fully final in Java 14. And then 3 preview features, and we'll talk about what that means. The text blocks feature, the pattern matching feature, and the records feature, which I think is one of the most exciting ones in this release. So these are 4 language changes. But before we go into those, there's also a very small, but I think very useful feature in Java 14 that I would like to highlight as well. And this feature has everything to do with this man. Maybe you recognize the picture. It's Tony Hoare, or I should say Sir Tony Hoare, because he has been knighted for all of his efforts in computer science. However, even though he's a pretty smart guy, he did make a mistake that is haunting us to this very day. So he calls this his billion-dollar mistake. And some people might know that we're talking here about null pointers or the null reference, which is one of his inventions when creating a programming language. And I think we've all run into this little beast, right? The null pointer exception in Java. So null pointers are very, very annoying, not because they break your code, but also because they're sometimes pretty hard to debug. Yes, when you get a null pointer exception, you get a line number. But what happens if you open the source file, this example class that we have here, and you go to line 5, and you see something like this. You're calling method A, and then on the result you call B, and then you read a field C, and then you call do something on it. So where's the null here? Well, it's pretty hard to tell. So if you want to find out, there are ways to do this. One example would be to break up this expression into multiple statements and then see where it breaks. But obviously this is not really ideal. And I think the change that has come in Java 14 is a very, very welcome addition. This very small and useful feature is a flag that you can set on the JVM called show code details in exception messages. And I would say better late than never, because if we would have had this from the start, it would have saved at least me a lot of time. I'm not afraid to admit that I've had null pointer exceptions as well. It's just a fact of life. And if you enable this flag on the JVM while running your code, you don't have to recompile, just run your existing bytecode with this flag enabled on the JVM. Then what you get is a much more informative null pointer exception. So here you see that the null pointer exception as a message says I cannot invoke the do something method on something of value class C. So that means that the field C that we're dereferencing in the expression here is the one that returns null. And it also tells us this in the second part of this message, the example A, dot B method call and dot C field. This sub-expression is the expression that results in a null. So this really pinpoints what's happening, and this also works very nicely when working with arrays and array indexes and stuff like that. Highly recommend enabling this feature, playing around and seeing how it can help you debug null pointer exceptions faster. Of course, we all strive to avoid them, but when you have them, this is a pretty useful feature. But again, this wasn't really a language change, and we're here to talk about the language changes. So let's dive into the first one, switch expressions. Like I said, out of the 4 language changes that we're going to look at, switch expressions are the only one that are not in preview in this release. That means that if you're going to use JDK 14, you can just start using switch expressions right away. They're now part of the Java language specification. They're in the compiler, in the mainstream compiler, and you can use them as is. Now, when you signed up for this webinar, you got a link to a GitHub repository, which you see here as well. And when you clone this repository in the master branch, there's the starting point code that I'm going to use for some of the live coding demos. So if you want, you can clone this repo, open it up, and work along with me. You can also try it later. There's also a branch called Java 14 in this repo where all the end results are, so you can check it out afterwards. So no pressure, you don't have to do anything, you can just watch me, but if you want to, you can open up your IDE and start using this project to code along with me with these new features. And the README in this repo has more details should you need it. Now, instead of talking about this feature, let's just open up the IDE and look at what it does and how it works. So let's go to IntelliJ. I'm going to use IntelliJ 2020, which is the one that has Java 14 support. So if you have a JDK 14 downloaded and installed, you point IntelliJ to it, you can start using Java 14 features right away. Now what we have here is not a switch expression, but a old school switch statement. And the idea here is that I have some kind of input, a string here with a product, and I want to find out the origin of the products in terms of which locale they come from. Now, if I do this using a traditional switch statement, I need to have a variable which will hold my result, and it needs to be a mutable variable because in the switch statement we're going to assign whatever result we want to based on the case that matches. And then inside of this case we see that inside of the switch we see that we have multiple cases, some of which are combined with this rather interesting stacked syntax and the colons, and every colon is followed by multiple statements in a switch statement. Now, you've probably all made the mistake of forgetting the break here. So when you actually run the code and this case matches and these statements are executed and you forget the break, then the switch statement automatically falls through to the next case and starts executing those. That can be awkward. So that's something that's really not that nice in this pattern. And all in all, it's quite verbose for what we're trying to do. We're just trying to match a few elements to their resulting locales. So what we can do with Java 14 is turn this switch statement into a switch expression. And I'm going to do this by first assigning the switch directly to the variable. And what I need to do here is I need to put a semicolon at the end of this assignment statement, because what's inside here is now an expression, the switch, but as a whole, this is still a statement, of course, which we need to terminate with a semicolon. And now we have turned this into somewhat of a switch expression, but it's still not syntactically valid. We also need to look at the cases themselves. And there are some interesting changes there. So what you can do with the new switch expression syntax is you can combine cases, not with this stacked syntax, but instead using comma-separated cases, which already cleans up a little bit. And then the most interesting change is that rather than having a colon and then a bunch of statements, we can replace this with an arrow. And the arrow can be followed by an expression. And in this case, it can just simply be the value that we want to return for this case when it matches. And this expression is what will be assigned to our variable here if the case burger or case donut matches. Now the interesting thing is that the semantics of the arrow also imply that there's no fall through. So we don't need to break anymore. That also nicely cleans up. And in this case, we have our first case done. We can apply the same transformation to the other cases as well. We say, okay, cheese maps to the language tag NL. We also don't need a break here. So let's remove that. And then we can also do the same for maple syrup, which maps to Canada. There we go. And our default case similarly also directly results in a value that will be assigned to the variable here. And with that, we have a fully functioning and fully valid switch expression. So the nice thing here is that we cleaned up quite some syntactic noise. And we made it absolutely clear that this switch is about producing a value instead of assigning to some variable as a side effect, which is what we did before. So just for good measure, let's run this code. And we expect, of course, the language tag NL to come out because we matched on cheese. That's actually what we see, so that's good. Now, one of the things that you might be wondering about is, okay, if I have a single value or a single expression here, that's nice. But what if I do want to have multiple statements here resulting in some value? Well, that's also still possible with switch expressions. So what I can do is I can open a block after the arrow, and this block should, in the end, return a value or yield a value. Now, they could have used maybe an existing keyword to do this, and they tried this in previous iterations of the feature. But it was a bit awkward, and we cannot use the return keyword here because return means returning from the actual method, which is not what we mean. So what they instead chose to do is they introduced a new keyword called yield, meaning that when this block ends, when all the statements that we're going to do here, for example, we can do a system out where we say, okay, just print the product that was matched because it can be either burger or donut. But in the end, we yield the same value, so the locale US. So this is something that you still can do by introducing this block that yields the value in the end. Now, interestingly, this yield keyword will probably also serve a purpose for other new features in the Java language, if we're going more towards maybe generators like you have in Python. So I think it's a good addition to have in Java, but for now it's only used with switch expressions. On the other hand, what you can also do in switch expressions, which you could not do before with switch statements, is have actually properly scoped variables inside of the right-hand side of the switch case. So here we could say, for example, we have a string temp, which is, let's say, the product to uppercase. There we go. And then we print this temp value. Now, if we want to have another block here, for example, we're going to yield the Canada value here. And then we're going to say, here we also want to print something from temp. Then we see, okay, temp is not in scope. because it's in scope only for this block, only for the case that matches burger and donut, then we can actually introduce the same variable with the same name here, and it's properly scoped, and we can say, oh, Canada, there we go. And this way, the blocks on the right-hand side actually behave like you would expect. With switch statements, there was a global scope for everything that happens on the right-hand side of the cases. That's not the case with switch expressions anymore. So all in all, this yields a pretty nice pattern for switches where you actually want to produce a value from each case that matches. Now you need a default case if you're matching on a value that has infinite amount of opportunities. If you're switching on something that's limited, like an enum, the compiler can check for you if your switch is exhaustive. And if it's exhaustive, then you don't even need the default case anymore. So that's also nice. So that sort of sums up what you can do with switch expressions. Now, if you go back and take a step back, and then some people might wonder, okay, does this replace switch statements? No, it's actually not a replacement. It's something additional that you can use as of Java 14. You can even mix and match some of the new syntax elements. So for example, what we see here is that we can also have a switch expression where we use the colon syntax inside of the cases. So then we need to have statements on the right-hand side rather than an expression. And a statement could, in this case, be yield some value. So that's something that you can now do. You could also, conversely, also in a switch statement, start using the arrow rather than the colon. And maybe do a statement on the right-hand side, and then there's no implied fall-through anymore. So in this example, if case 1 matches, it will assign month name January to the month name variable, and it will not fall through to the second case 2, which would have been the case in original switch statements where you use a colon. Now, I'm not saying that you necessarily should mix and match these worlds, because it can be a bit daunting in terms of the combination and explosion of things that can happen. But it's good to know that this is how it's designed and this is how it's implemented. So what's nicer is that the switch expressions will be even better to use in combination with other upcoming Java language features like pattern matching, which we're going to look at. But stay tuned, we'll get back to that later as well. So for now, Betjan, I'm interested to hear if there are any questions already on the chat around switch expressions.
Yes, there were a couple of questions
cool.
About switch expressions, but you answered them all already.
Oh, nice.
There was a question about the null pointer details flag that you talked about in the beginning. Is there a performance penalty if you enable this?
Is there a performance penalty? The performance penalty is there, but you only pay it once the exception is triggered and created. So I would say, don't worry about this. This will not hurt your normal flow of your application. Also, good to know, this is a feature that has been present in the SAP JVM for multiple years already. So it's a very well thought out and hardened feature. It's not something that has been cooked up in the last few months. It's something that has been contributed by SAP. I think the only reason why it's not enabled by default is not because of performance, but it's because it changes the output of the JVM in case of a null pointer exception. And there might be tooling around that, well, might break in these cases. So they're being a bit conservative in not enabling this now. I might very well see this being enabled in a future version of Java by default, because it's just so useful. Yeah.
So to summarize, the only penalty that might be there is that the user sees the error message a bit later on the screen.
Exactly.
But that's fine.
I think that's fair.
Okay. So just this afternoon, I was discussing with a colleague about writing tests and comparing the result of a test with the outcome from, let's say, a service that produces JSON or something. And we were struggling to find a good way to position the expected JSON result inside our Java code, because we didn't really ever have a good way to put it in a readable way, like inside a test method. So I have a hunch that you might be sharing some things that will change this right now.
That's a great bridge to the next feature, text blocks. Text blocks are all about making multi-line strings in Java easier to work with. And indeed, one of the use cases there is definitely on the testing side and being able to express your expectations in a nice way in code. So let's dive in. But before we do, it's good to note that text blocks are a preview feature, which means that if you're downloading JDK 14, you do need to add an enable preview flag to the compiler and the runtime to use this feature. If you're using IntelliJ, like I do, This means that in your project settings, you will need to switch not to the Java 14 language level, but you need to switch to the Java 14 preview language level. And then these features are unlocked. So I've already done that. And if we switch to the second class, the second directory that we have in the repository, where we have a text blocks main, you can see that I have a little application here that tries to launch a script engine manager, and we want to put some JavaScript into it. And we want to spread this out over multiple lines, because doing this on a single line would be very unreadable. But still, if you split it out over multiple lines in Java, it's still a bit messy, right? Because we need these new line escapes in here. We need to escape the double quotes if we want to use this inside of the JavaScript. We need to do the string concatenation. So all in all, this is not a very nice way of doing multi-line strings. Now with text blocks, we can define this differently. We can say we have a string JS, and we open this string with 3 double quotes and a new line. So the new line that's behind these 3 double quotes is mandatory. We can see that IntelliJ already autocompletes with 3 double quotes to close off as well. And now within this text block, we can do whatever you want in multiple lines. So I'm going to insert the same piece of code that we have above, but without all these syntactic noise. So we have the new lines just as new lines in our source code here, and we have the quotes without any escaping here. And if we actually compile this piece of JavaScript and we print it, there we go. Let's do a sys out of the new string block there as well. When we do this, we actually get the original output of our concatenated string, and we see the output of the text block. And you see it's exactly the same, but in source code it looks much, much nicer without all of the escaping and the noise around it. So what happens is that the new lines that are in the source code are preserved into the resulting string that you get from this text block. Now, looking at what happens here is pretty interesting, because we also saw that the indentation is preserved, but not all indentation of this text block. So what this feature does is it distinguishes between essential and non-essential indentation. And essential indentation is everything that happens inside of the text block. So here, this would be marked as essential indentation. And non-essential indentation is everything that we've put into the source code to make it line up nicely with the rest of our code. So here, this would be stripped as incidental or non-essential whitespace. Now we can play with this a little bit, because the non-essential whitespace is determined based on also where you place the closing character of your text block. So if we move this back a bit, and I'm going to zoom in a little bit, you can see that IntelliJ helpfully displays a green line here, which indicates where the essential whitespace of our text block now starts. So now, if we would run and print this, we would see that this indentation is also preserved. So let's try that. There we go. We see that in the second output, we do now have also the indentation preserved here. So this is a very, very nice way to lay out your multi-line strings in a better way. There are also some new things happening here. The new lines at the ending of every line, they're not actually preserved by the compiler, but they're actually normalized by the compiler. So if you save a source file on Windows, where you have a different new line than on Unix, it will all be normalized in the resulting string that ends up in the class file to Unix new lines. So it's also very useful to know. So this way you won't get any conflicts between source files edited on Windows or Unix or Mac. So that's a very nifty and handy feature. Furthermore, sometimes you do want to have multiple lines in your source code, but you might want to have the string as a single contiguous string in your Java code, in your resulting Java string. So what you can do there is use a continuation character. That's also pretty well known from shell scripting, where you say, okay, just adding a slash to the end of lines here. Ooh, there you go. Just adding a slash means that the new lines that we have in our source code will not end up in the resulting string. So if we run this now, you will see that by adding these, the first 3 lines are all concatenated onto a single line, whereas the new line right here is still preserved because we don't have the continuation character. So this is something that you can easily do. And one last thing that I want to mention here is that when stripping the non-essential white space from a text block, all trailing white space is trimmed as well. But sometimes you do want to have some white space. So what you can do there is you can use a new escape sequence called /s, which stands for a single space. And you can add this, and you can even prepend it with some explicit spaces, and then end with this marker here. And now this white space will be preserved in the resulting string. So a lot of details and a lot of things, I think, to play around with in terms of text blocks. But all in all, a great addition to the Java language. And when I think about applications for this feature at Picnic, looking at our typical code bases, I see a few very good places where we can apply this. So one of them is, for example, in OpenAPI or Swagger documentation on our endpoints, where you have this description field, where we now try to keep things short. And if you have multiple lines, then it looks really, really ugly if you concatenate those. So it's a really great place where we can actually start using text blocks. And you can add the markdown there, and it will end up in your Swagger documentation. So that's a place where I think these will really, really shine. The other one is similar to what Bert-Jan mentioned. So if you have some piece of JSON that you want to verify in your test code, you can now easily inline this with a nice indentation, and by just copying and pasting in the actual JSON that you want to assert on and not having to escape it. So that's something that's definitely a plus. Of course, when these get bigger and bigger, you might still want to put them in an external file and load it. But now, at least for most common cases, you don't have to do that anymore. And another case, I think, where this is really powerful is when you have some templating in your current code. So this is an example of where we create push messages for Google Cloud Messaging. There you have some kind of JSON format again, where we need to put in a title and a message. And the nice thing is that we can just put this template in there as a text block. And instead of calling string.format and then passing in the text block as an argument, there's a new method introduced called for method that you can call on a string. And you only have to pass in the variables that you want to substitute in a string that you call formatted on. As shown here, we substitute the title and the message. And then the layout of this piece of code is also really, really nice. So these are three use cases where I think text blocks will really add value, and where I definitely see them used. But of course, it's still a preview feature, so this still needs to be finalized before we can use it in real Java code. So Bert-Jan, talking about text blocks, are there any things that popped up for the listeners there in terms of questions?
Yes, there's one question about how the compiler determines the indentation of a string. So in the example for the OpenAPI specification, the closing quotes were at the end of the string, so not on a new line, but at the end. Yeah. Do you know how the essential and non-essential indentation is determined?
I do have a rough outline. The whole algorithm is described in the Java enhancement proposal, which I'll link to later as well. But the gist of it is that, let me switch back to the IDE, is that if you have this closing delimiter, then what happens is that it will be determined based on the position of this closing delimiter, as I've shown. You can also choose not to have this new line, and you can actually put it right behind the last character in your last line. And what happens then is that the incidental non-essential indentation will be determined on the first character that appears in your text block. So if I move my function one step back, that means that the rest will all be indented in the resulting string. One space will be preserved. And this is based on the front-running, so to say, character position of any of the lines that are in your text block. So I hope that this makes it a little bit clear, a little bit more intuitive. If you want to have the real description of the algorithm that they apply, highly recommend looking at the Java enhancement proposal that goes with the feature.
All right.
Yeah.
So next question, I think you partly answered. What about using variables in text blocks? Is it possible? So you showed string formatting. Yeah. Is there a way to insert or interpolate variables?
Yeah. So some other languages have something similar, like Scala, where you can also do interpolation and insert expressions or variables into strings. That is not what you can do with text blocks. that might come at a later point in time as a separate feature, also for regular strings. But for now, if you want to do interpolation, you will have to need this formatting approach that I've just shown, where you just place the placeholders with the appropriate characters into the string, and then you use formatted to actually provide the parameters.
Yeah, so I guess this will only be really useful if you do not have too much arguments. Let's say if you want to use it to build a templating system and you have 200 string arguments, then it will be less usable.
Then it might be become a bit awkward. Yeah, I definitely agree.
Depending on how good you can count. So,
True.
And there was a question about why has the feature been in preview so long already? I think it's still a preview feature in Java 14, right?
It's the second time this feature is in preview. And they extended the round of preview because there has been feedback from the preview round. And the thing that has changed is that they introduced this continuation character that I've shown. So this is something that came back from the community as something that will be useful. And they added this new /s escape sequence. And I think it's good that they don't just make these changes and call it final, but they do just another round of preview just to ensure that everything works out as intended. I expect this feature to be final in the next release of Java, so in Java 15. However, there are...
so I guess that's the idea of preview releases, right? You give a preview, you process feedback, and once everybody shuts up, you make it final?
Sort of. At least if there are real comments that the JDK team actually thinks that are worth addressing, then that's how it works. Yeah.
Okay, that's it for the questions for text blocks.
Nice.
So let's move on.
Okay. Then let's have a look at pattern matching. So this one is relatively minor, but it does pave the way for some other features that are coming up in new releases of Java. So as such, I think it's a nice illustration of how Java currently evolves, also in a stepwise manner. Rather than having these big releases with very, very big features, we get them piece by piece, first as preview features, then as final features, and then these features even start building on top of each other. So for pattern matching, I'm going to directly switch to my IDE and go to the third subdirectory in the repo. So what you see there is a pretty common pattern in code. So here I have some object that I don't know the type of. Well, I do know it, but it's typed as object. And then we want to do something based on the type. So what we see here is a pattern where actually three things happen. So we have some kind of test where we actually test whether the object is an instance of, in this case, string. Then if this test is true, we introduce a temporary variable to hold a actual string pointer to this object, and we do this by by casting. Now there's quite some redundancy in this setup. We see the string coming back 3 times. We have to introduce this temporary variable just to be able to use this object as a string, even though inside of this if we already know that it's a string. So this is one of the first things that they wanted to tackle using pattern matching. So what you can do in Java 14 with the pattern matching preview feature is you can introduce a so-called type pattern as the right-hand side of instance of. So we can say here, rather than message instance of string, we can actually say message instance of string message string, where what we have here is a type pattern. So this consists of the type name and a binding variable. And this variable will be bound to message only if it's actually an instance of string. And that's very handy because the compiler is now so smart that it knows that if this instance of and type pattern check succeeds, then we actually, inside of this block, already have access to this message string variable. And it contains, and we don't have to cast anymore. We don't have to introduce a separate variable anymore. You can see that message string is actually of type string. So this is something that you can do. Obviously, if we were going to try to use message string in the else branch, then we cannot, because here it is not in scope, because we know that if we're here, then the pattern, the type pattern has failed, and it will not be able to bind to this message string variable. So we would have to do something else here. Now, the interesting thing is that whether we can use message string here really depends on what kind of check we have on the if. So if we were going to invert this and say, okay, not message instance of message string, then we would have the opposite problem. where the compiler knows, okay, if we're in this branch of the if, then we actually cannot use message string because, well, the pattern, the type pattern check has failed. And we are able to use it in the else branch because it knows, well, there we do know that it's failed. So clearly there's some compiler smarts going on here, and there's some type information being propagated based on the interpretation of how this pattern is applied. So in that sense, it's quite an advanced feature. But other than that, it is not more than this at the moment. So it's really geared towards these situations where you have this very common pattern where you test on a type, you introduce a temporary variable, and then you cast. So you can all fold this into a single type pattern match using this new feature. Now, there are some familiar use cases for this. One which I frequently encounter is something like this. If you're implementing equals methods, where you say, okay, we can do this nicely in one line, where we say return O instance of my class, and then in the second clause of the end, we cast O to my class, and then we can access the name field, and then we call equals, and we compare it to our current name in the object. If we're going to use this new instance of pattern matching, we can actually see that we can do this more concisely. Where we say, okay, we return the O instance of my class M, where we use the type pattern there, and then even here on the right-hand side of the end, we already know that the first check has succeeded, so we can use M as my class without casting and compare the name directly based on the equals of the name. So this is just one example. Of course, there are many other places where you have instance of and this pattern coming up. So that's a useful improvement. However, I do want to highlight that this is not the end of the road for this feature. So this is a first start, but there's also some ideas in the direction of combining, for example, the switch expressions that we saw with these type patterns that we saw. So instead of combining a type pattern with instance of, we can also combine it with cases, where we say, okay, if this object is actually of type big decimal, then we bind it to B, and then on the right-hand side of this, we can start using it as a big decimal without casting, which is similar to what we did with instance of, but geared towards switch expressions in this case. Now, to be fair, this is not in Java 14, but I do envision that this is a future direction of how this feature will evolve. All right, that's what I wanted to share around this somewhat smaller feature of pattern matching using instance of. So, Bert-Jan, are there any questions about this?
I think you explained everything perfectly because there's not a single question on pattern matching.
Nice. That means that we can move on to something that I think is really interesting to us as Java developers from a broader perspective, and that's the records feature. Now, records are all about being able to model immutable data better in the Java language. So before showing the example and before showing how you can create and use records, I want to give you sort of a frame of reference of how to think about this feature. Because it's easy to sort of cast it into your vision of what this feature should be. But I think it's important to know what the rationale, what the ideas of the JDK designers were when they started creating this feature. And the idea of records is to introduce a new form of a sort of restricted class that allows you to model data as data. And what do we mean by that? Well, we all know, of course, the Java beans that we use to model data, that we use to create anemic domain objects, for example. But they're just a pattern, right? They're just something that we tell each other, this is how we should do it. But it's really something that is not something that's surfaced at the language level. The intention is not really revealed at the level at which we create these abstractions. So records try to do this in a better way. Now, you can also think of them as nominal tuples. So some languages have tuples where you can just combine several values and pass them around as a single unit. And these are not named, so they're just a bunch of things thrown together. Java, with records, now has something similar, only we give it a meaningful name. So every record has a name. That's why I say nominal tuples. But still, you should think of a record as just a collection of data, a collection of immutable data that belongs together in some meaningful way that you want to pass around. Now, Conversely, there are also some ways in which people think or maybe hope around this feature, which are not quite appropriate. So it's not in principle meant as a boilerplate reduction mechanism, just to alleviate all of your boilerplate around every kind of data class that you ever had in your source code. This is not what this is about. It might be a nice side effect, but this is not what's actually one of the goals here. It is also not meant to replace the standard that we have with Java Beans. Java Beans are about mutable data. Records are about modeling immutable data in Java source code in a nice and concise way. Yes, there's some overlap, and there might be a shift away from Java Beans for some use cases, but this is not intended to, for example, replace the Java Beans conventions that we are used to when working with JPA and other kinds of frameworks. So if that's your expectation, then I can disappoint you already. This is not how you should think of it. It is also not an implementation of value types in the language. There's development around value types that's going on, parallel to records, and these two worlds might come together. But value types are very much about how is an object laid out in the JVM, how can we efficiently represent it, how can we compactly store it in memory. That is not what records are about. As I said, records are a tool for us as developers to model immutable data in Java. So before we move at some of the things that I think will be affected, for example, in our picnic code bases, let's first have a look at what records are all about. So this is a typical piece of code that you might encounter where you model immutable data without records. So you have a class, you have some private final fields, and you need to create a constructor, some getters, the equals and the hash code and the string. This is all pretty boilerplate. And yes, our IDE can help us write this, but we all know how it goes. This helps the first time, but if you want to change something, then it's cumbersome and you maybe forget to add something to the toString. So all in all, this is not a really great place to be in. So then several libraries popped up, and I'll talk a bit more about this. Libraries like immutables and Lombok. But all in all, these are all workarounds to the fact that we don't really have a way to model just a data holder in Java. Now, this changes with records. So what I can do is I can create a new class. Let's call it product. And you can see that IntelliJ already knows about records as a preview feature. I can say I want this to be a record. And what I get is a very simple record, a public record where this new keyword indicates that this is a data holder class. And then we have a product and there's parentheses. And within these parentheses, we can add so-called components for this record. So these are the data elements of this record. So let's say I want to give a product a name. I want to give it a brand, and I want to give it a price. Let's go. And this is all we need to actually have a fully functional record. So what we can do now is we can replace this old style product with our new record. And then we can still invoke a constructor, which is magically appearing based on the component declarations that we have in our record. We can also see that if we look at the completions that are available on the records, we see that there's an accessor method for each of the components. Remember, this is immutable data, so we cannot change it anymore after creating it. So we can only access the elements, and we have a brand, a price, and a name. Again, the choice has been made here to do accessor methods without get, because there's no equivalent set. And again, this is not meant to replace the Java Beans standard. So they've chosen to do this like this. And there's also a toString, hash code, and equals that has been generated that are all based on the components that we provide to the record. So just to show this, let's run this and see that we need to run a different one. There we go. We get a very nice output containing all the elements, all the components of the record that we have. And when we look at the code that has been compiled, it's also instructive to look a little bit under the hood. There we can see that in this product class, it actually extends something called Java lang record, which also means that a record cannot extend any other class or any other record. That's a limitation to records to make them work the way they do. But still, we see the same pattern that we had in our old product. So we see the private final fields, we see the constructor that has been generated for us, we see toString, hashcode, and equals, and all the accessor methods. So it's exactly as you would expect. There are some more limitations that you need to keep in mind when working with records. You cannot just add a new field. So we cannot say just add a public, let's say int discount is 10 to this. As you can see, IntelliJ will complain because all the state of this record should be encapsulated in the components that you declare here. So you can of course have static variables if you want to, but in the end all the states should be managed through the components that are mentioned here. Now, if you want to, you can still override and provide your own implementation of the generated methods. For example, if you want to do a custom toString, you can do that. Say string to string, there we go. And then let's say return, if we only want to include the name with an arrow, and let's do it like this. There we go. Formatted, we just learned about this, so we can say we put in the name here. You see we can just access this private field, of course, from the string to string implementation method. Now if we run the same application again, you will see that the output now uses our overridden toString. So you can do this for any generated method that's on here. You can also, of course, add additional instance methods that all have access to these final fields, so that you can use them to add some derived information based on the name, brand, price, or whatever. But what's more interesting for these data holders is that you can also do some custom work in the constructor. Now, if you don't do anything, there will be a default constructor that just assigns the fields and be done with it. But you can also, if you want to, create a constructor yourself. Now, you can repeat all the elements here to the constructor, like string name, string brand, and price. But you can also omit it. So you can also do a compact constructor for records, which is nice. And then you have implied access to these name, brand, and price components. So what we can do here is we can, for example, do validation. You can say if price, or let's say if brand dot is blank, then we can throw new legal argument exception. Brand must not be blank. There we go. So that's something that you can do. What's interesting is that we don't have to do assignments here. Every field that has not been assigned by a statement in my explicit constructor code here will be implicitly assigned. So if we run this, and let's remove the toString so that we can see all the components again. So if we run this again, you will see that we still have assignments to all of the components of our record. What's more, we can even customize these assignments. So let's say if we want to say price is less than 100, then we want to say this dot price is 100. There you go. We don't want to sell cheap products. And then it says, okay, you're assigning it now, but it might not have been initialized. So you also need to do a fallback where we say this dot price is let's say price. There we go. In the else branch here, like this. And now if we have a product where the price is below 50, for example, and we run this again, you will see that the price will have been corrected to 100. So this compact constructor is the place where you should do validations and you should do transformations on any incoming data of your record. Now, all in all, this is pretty nifty, I think. What's also very nice is that records cannot just be top-level declarations. We can also introduce them locally, for example, in a method. So we can say record person is string name int age. There we go. And then we can start using this. And this is very handy, for example, in stream pipelines. Sometimes you want to pass multiple return values from one stage in your stream to the next one. Then you can either use this pair class that everyone introduces and maybe have a tuple class that you've created yourself. But now you can actually create a very well-named abstraction, like person here, and you can start using that to aggregate and deconstruct information between different parts in your stream pipeline. So I think all in all, records will really change the way we use Java. Now, if I look at how we deal with these kind of patterns currently at Picnic, we are firmly on the immutable data bandwagon. So a lot of our classes, a lot of our data classes are currently built using immutables. And immutables is an annotation processor tool that, based on annotations that you put on an abstract type, generates an immutable type for you. Now, it's a very fancy library with lots of bells and whistles, so it goes very much beyond what records offer. But often you don't really need all those bells and whistles. So I do think a lot of use cases, like data transfer objects that we have in our endpoints, so that represent the data that goes into the JSON serializer and deserializer. These are really great candidates for use with records. The document classes that we use to put our data into what we use MongoDB, for example. There's also a great fit for these kind of immutable data classes because we don't use object relational mapping, object database mapping or anything. We do this based on these immutable classes. Anywhere where you're using map keys, for example, and you want to key on multiple values at once, it's very easy to, using a record, create a lightweight abstraction there that you can use as a key in the map. And like I said, I think it will be really useful to make more precise what you're actually doing in a stream pipeline if you're returning multiple values by, in a really lightweight way, introducing a record as an intermediate holder for this data. So there's also another library that's pretty popular called Lombok. This works a bit differently than immutables. It actually hooks into the compiler and it needs some IDE plugins to do all of its magic. But you can achieve similar outcomes. And again, there's more control than you have with records. What I like about records over Lombok and over immutables is that it's actually part of the language. That's something that's frictionless to use. Because Lombok, in my experience, does add friction to your development model in terms of tooling and in terms of being able to upgrade. You need to wait for Lombok to be ready as well. There's also a slight difference between to how some of the generated code works with these libraries. So both immutables and Lombok actually spin out either source code or bytecode for the equals and the hash code implementation. What's interesting about records is that they use a feature called invoke dynamic to, at runtime, create or select a suitable implementation for your equals and your toString and your hash code implementation. Which means if there's a more performant way to do things, to hash things, they can just build it into the JDK. You don't have to recompile any of your code, and you will benefit from this increased and this better implementation, because linking happens at runtime with this invoke dynamic bytecode. That's just a detail under the hood, but I think that's a really cool thing that they can do using the current records implementation. So again, records are really cool. Records are not the be-all, end-all replacements of all kind of data classes that we have in our current code bases. So there will be a place where you still want to use actual mutable Java beans, probably. But I do think this will get us thinking about the places where we can more easily and more frictionless introduce immutable data and use it using records in our code base. Now, if we start to look farther ahead, which I think we should, then we can definitely see that records also play a big role in terms of combining with other language features. So if you will look at the Java enhancement proposal of records later and some of the other literature around it, you will find this example where they've modeled sort of an expression tree as immutable records, where you have a constant expression, a plus expression. I think you've probably all seen this kind of pattern in your computer science courses if you've taken them. And the cool thing here is that besides being able to construct data easily, you could also use records to easily deconstruct and to decompose patterns. So that's what you see here. So if you combine records with pattern matching and with switch expressions, you can look forward to code like this, where you can say, okay, if I get some expression E, and if it's a constant expr, which is a record, and it actually has the variable I inside of it, then you can directly start using I on the right-hand side. You don't have to awkwardly extract it anymore. So this is another form of a pattern match beyond the type pattern match that we already saw, based on being able to deconstruct records. So again, this is not in Java 14, but this is definitely the direction I see things moving in. And it also nicely shows how all these features are not built in isolation, but they're built on top of each other to unlock really, really cool things. If you're a Scala programmer, for example, you most likely recognize this. This is already possible in Scala, of course, with switches and with case classes. I think we have a pretty good solid foundation in Java to actually get here over time as well. All right. Bert-Jan, before we move to this last part, are there any questions around records?
Obviously, records is a popular feature since we have loads of questions on records.
What I would have expected.
I think the first question is an obvious one that you also already partly answered. Right now, if you want to do something like records or data classes, you can use Lombok as value.
Yep.
You could use Kotlin's data classes, or you could take Java 14 and use records. Do you have any guidance on when to choose which? Is it possible to give any guidance there?
It's a bit too early to create like a checklist because the feature isn't even final. But to me, I think these libraries have always felt a little bit as a workaround to me. So to me, it makes sense that if you move to a version that includes the use of records, I would start by using those in places where you can. And only when you actually need to reach for some things that it doesn't offer, like mutability, which you can model using Lombok, but not using immutables and not using records, then reach for one of these alternatives. And like I said, if you actually have Lombok in your code, you've probably felt some of its pain, also in terms of your tooling. So I think giving up some features by going back to something that's in the language and that's in the platform might also be a good trade-off. But again, that's really up to your personal preferences as well. Yeah, I think that's the most that we can say for now about this.
Right. So two questions are kind of similar. Do records have inheritance? I think you could say no, because it already extends record and it's final, right?
So they can implement...
So can a record implement an interface?
Yeah. So it can implement an interface. And of course, this interface can have default methods and all kinds of other stuff to share implementations across records. So that's one way to go about it. But in the end, there should be no ambiguity about where the state of a record comes from. And if you have inheritance, well, then you have ambiguity there. We all know how hard it is to implement equals and hash code in the face of subclasses. This is complexity that is just avoided by not allowing this for records. So no, you cannot extend the class, but you can implement an interface with a record.
Okay.
Yeah.
So what if you want to do input validation, like with a value object, for example, check if a price is not negative or an email address is correctly formatted?
That's what you would do in the compact constructor, like I've shown, where you do a check, and if you don't want to accept it, you throw an exception. That's how you go about it. Yeah.
So you do it on initialization, basically.
Exactly. Yeah.
So what happens when the name of a variable collides with the object interface? For example, adding a field notify, which will create a notify method, which clashes with object.
Yeah. I think you just cannot do that. But I mean, we're live. We have an IDE, so let's just try it out and see what happens. Sure. So if in our product record we would say, okay, we want to have a string notify, then indeed we get an illegal record component name, because it does clash with something that's on the object indeed. Yeah. So there are a few reserved names that you just cannot use on a record. Yeah, good question.
So what can you tell about the performance of the generated equals, hash code and toString? There's a rumor that handwriting them is still faster.
Honestly, I've not looked into any benchmarks around this. I just know that the implementation uses invoke dynamics, so the first time you call it, it will be a bit more costly because it has to link to the actual implementation, or maybe even spin up the actual implementation at runtime. But over time, when this gets optimized, you will reap the benefits automatically rather than having to recompile. So yeah, there's a trade-off going on. If you want to have real benchmarks, sorry, I don't have numbers for you, but I can easily imagine this is affected a little bit by the first call being slower.
So the next question is a bit also related to text blocks. When you're overriding a toString method, would you recommend using text blocks for toString overrides in Java 14?
In terms of implementing this toString override, and if it's a multi-line toString, yeah, why not? I think that would definitely make sense. Yeah.
And also there, I think the argument would be that as long as they're not too much fields you need to interpolate, probably.
Sure. Yeah. That's.
Well, what when a field of a record is set to nil? Is this possible? What will happen?
As far as I know, there's no additional validation done in the generated constructor on nil values. So if you want to assign it nil, you can. Also, if you want to make something that's mutable part of the record, you can, right? You can just put any object type in there as a component, but you shouldn't, right? The idea is that if you only put either other records or other kinds of immutable data in there, then you will reap all of the benefits of records. Same goes for putting in nils. If you want to allow this, maybe for compatibility reasons, it's possible. But again, if you want to guard against this, this is something that you will have to do yourself in the compact constructor.
So I see that records are getting a lot of competition from Kotlin data classes. So here's another question. With Kotlin, you can create a copy of a data class, but basically an instance of a data class, and then change like one item. Is this is I think not possible with records? Do you feel this is limiting?
So there's no way of either getting a builder for records or getting a copy method, which essentially I think is what happens in the Kotlin data classes. I know the JDK team actually wants to have this functionality of being able to copy. What we need there, I think, is actually named parameters to work in Java. I think that's sort of the roadmap that they're sketching. So once we have that, we have a natural way of constructing records based on overriding just with a few of the components rather than all components being in place. So I think before that we will not get this functionality, and it's somewhat limiting. I agree, but then again, they want to do things right rather than actually spin and generate many more methods that will be obsolete in a later version of Java, and then we cannot remove it anymore.
There was a question about your code sample where you were determining a price. And the question is, isn't the else in this example superfluous, as the default path will lead to the price being set anyway?
So let's quickly switch back to IntelliJ. You mean this one? Yeah. I think this has to do with the automatic code that has been generated after this, because if I leave off this else, at least IntelliJ does compile, does complain. It might have already been assigned to. So in that sense, we have multiple assignments and it's a final field. So it makes sense to me that we need to put this in an else branch, right? So if it's less than 100, then we will assign 100 to it, and then we come out of the if, and then we try to assign it again. Well, that cannot happen because it's a final field. So that's why I need to put it in the else here.
So how about serialization? Are records serializable? Is there any problems because fields do not have a get prefix? So they are fully compatible with Java serialization. If you want to be compatible with a other serialization framework that depends on the Java Bean standard, then you can either rely on field serialization. That works because the fields just have these names. If you want to do it with methods, you can either add these methods by hand, or you can do nasty stuff like, okay, I'm going to call my component getName rather than name. So that's possible. But like I said, this is not meant as a replacement for the Java Bean standard, so it has not been built with that in mind. So if your serialization framework of choice does not know about records yet, the chances are that you do need a little bit of massaging to get it to work together. But I've used records together with Jackson, for example, based on fields, and that works fine. Yeah. Okay, so why do we need curly braces after the inline declaration of a record? It sounds a bit, useless or not really necessary.
Yeah. Actually, that's a nice discussion that happened this week on the OpenJDK mailing list, where they asked the same question. And this is all about making the syntax uniform. So while probably they could make it work, even though there are some syntactical ambiguities if you leave it off, they just chose, well, making it mandatory and just making it clear that you always need it is just the easiest way for developers to actually deal with this. So that's what he chose. Again, yeah, it's something out of the desire for uniformity and not have too many exceptions in the grammar of the language. Yeah.
How do you feel about using records for object relational mapping entities? Can we annotate fields in records?
So that's actually two questions in one. I think I'll answer the last one because it's related to the language feature. Yeah, you can add annotations on components and it will be propagated to all the elements. So I believe to the fields and to the method. So that can be picked up by your favorite framework of choice to do well, whatever it needs to do based on the annotations. Yeah.
Now about bean validation. Can we use bean validation on records?
Bean validation, I'm not sure how much it hinges on the get prefix being there for the properties. But other than that, if you put the bean validation constraints on the fields and you just pass in the record instance, and it does validation based on the fields, there should be no difference between a regular Java class that has the same kind of fields with the same annotations. Yeah.
So final question about records. If you're adding new fields to records, what about binary backward compatibility?
So in terms of Java serialization, I guess the question that is, it will be, as far as I know, incompatible. So you will need to use the serialization methods yourself to actually, if you want to have backward compatibility, you want to serialize and deserialize in a special way. So there, it's more or less the same as with regular Java classes, where you add something and it will lead to a different serialization, binary serialization. Yeah. Cool.
All right. So that's it for the questions.
Yeah. So I have one last section because I already told there's a little bit more to Java 14 than these language changes. Won't be able to go into these, but just to give you an idea, there have been some pretty interesting garbage collection changes, performance improvements for the G1 garbage collector, which is the default, starting as of Java 9 already. Also on the ZGC garbage collector, which is an experimental collector, but a very, very promising one, which offers really low pause times for garbage collection. Also fixed, so not scaling with the amount of memory that you use. And they actually introduced support for Windows and for macOS. Before this, it was only available in Linux. So I think this means that the ZGC garbage collector is also moving more and more towards being a real feature rather than an experimental feature. So that's definitely one to keep an eye on. There's also a Java packaging tool that is a replacement for another tool that was already part of the sort of Java FX suite, where you can bundle up your application and ship it as a single executable to your customers. So this allows you to create an MSI or an EXE or a Debian package right from the command line using the JPackage tool. Really cool development, but again, this is also something that's incubating, so something to try out, to give feedback on, but not something that you would use in production already. And then there's some new APIs around for memory access and accessing non-volatile memory using byte buffers. Like I said, a bit too deep to go into now, but if you're interested in this, there are enhancement proposals for each of these changes, including the language changes that we talked about. And I highly recommend you go to openjdk.java.net/projects/jdk/14, which lists all these Java enhancement proposals. And these will give you much more details, much more in-depth details about the topics that we could not go into. So really highly recommend it as a resource of learning more about Java 14. And with that, I think we've come to the end of this first Java Masterclass with NLJUG. I really, really want to thank you for being here and for joining us in this, well, what's really an experiment, but I hope we all can move forward and create more of these masterclasses and have fun together online. So again, thank you. Also, thank you, Bert-Jan and the crew for organizing this. If you're interested in more about this, feel free to ping me. The repository will still be online, so you can clone it and play around with it yourself. If you're interested in helping us out at this special time where we as an essential company are pretty busy with all things Java, I highly encourage you to go to jointhepicnic.app and see what's possible there. And with that, I think over to you, Bert-Jan, for some final closing words. Thank you very much, everyone.
Yes, thank you, Sander, for sharing your knowledge with us. It was enlightening. So this wraps up the first NLJUG live stream ever. I hope you all had a great time. As with all live streams, if you like this stream, please like it on YouTube. Subscribe to the NLJUG channel for more interesting Java content. If you're not an NLJUG member yet, you can sign up at nljug.org so you won't miss any future events. We'll send an evaluation via email to everybody who signed up. So please let us know what you thought about the session, and maybe let us know any new topics you'd like us to discuss in future streams. Thank you all a lot for watching, and hope to see you all again soon. Thanks, and bye. Have a good night.